All right, so this is AP Calculus. We're on worksheet 5-7. Here are the solutions. These questions need to be written slightly better, but let's say that my graph starts and ends right here. So there's no graph at 1, there's no graph at 5. It strictly is between 2 and 4. So what I need to do in terms of my notation is I need to say, hey, my integral, my area that I'm going to find is between 2 and 4. And what is the function? Well, my function has a constant height of 2, so it's a constant function of 2. And I'll just say 2, I don't know, dx, dt. It doesn't really matter. I'm going to go dx. Sure, why not? If I do that integration, I can do it algebraically, but I much prefer doing it graphically. Graphically, what's happening here is I can come and make some lines. Graphically, I have these lines. I always go to the x-axis, right? Your area is always bounded between your curve or your function and your x-axis. So I go ahead and ask myself, okay, what are the dimensions? The dimensions are 2 by 2. 2 times 2 is 4, so this has an area of 4. My answer is 4. Of course, you can do it algebraically, and to check your work, you should still end with 4. And I can say antiderivative of 2 is 2x, evaluation bar between 2 and 4, and then you get, okay, that's going to be 4 times 2, or 2 times 4 rather. 2 times 4 minus 2 times 2, and that should still equal 4, and it is, because 8 minus 4 is 2.
Do we need to do that?
Or 8 minus 4 is 4. If you want to check your work, you should do this. I want to check my work, so I will be doing this unless I run out of room. So, this next problem, even though that it's not defined at this point to -2, I'm still going to make my bars between 2 and 4, and it's not going to change the area. Missing 1 point, which is infinitesimally small, is not going to change the area. So my area here is going to be -4 because it is below the x-axis. So how do I write that? I'm going to say it's between 2 and 4 still. Of what function? My function now is -2. And I'll say dx because I do have an x-axis. It does have an x-axis, so I should be using the variable x. All right, how do I do that algebraically? Well, there is a shortcut. And did I ever write down the shortcut in the notes? No, I guess I'll teach you that shortcut some other time. So this is going to be -2x, evaluation bar between 4 and 2. That's going to be -2 times 4 minus -2 times 2, and that will equal -4. Final answer, box it. I should be boxing that one as well. All right, I'm on to number 3 now. The graph is already there, so I just need to go ahead and make my lines. Clearly ends over here at 4. Oop, make this slightly better. Okay, so what is my area? Well, it's base, which is 4, times height, which is 4. 4 times 4 is 16, but half of that, because it's a triangle, half of 16 is 8. Let's see if we can calculate it the other way. So my bounds are going to be between 0 and 4. 0 and 4. What is this function? This function is just x. 1x plus 0, if you will. But I'm just going to say x dx. If you don't like x dx, and you will say 1x plus 0, and then all that quantity dx. That is totally correct as well. This is a little bit more simplified, though. So from here, the antiderivative of x is x squared over 2. Evaluation bar between 0 and 4. When I plug in 4, that's going to be 16 over 2 minus whenever I plug in 0, I get 0. And the answer here is clearly 8. Final answer, box it. Yes, Gio.
Number 2 in the homework, or like the website,
Yes.
it says it's 6, but you have a different graph right
Ooh, okay. So I might need to go change that. Was it between 1 and 4? Is that why?
there. It was between 1 and, it was between 2 and 4, but the height was 3.
Oh, the height was -3. Okay. Well, I'm just going to stick with this from now on because I don't want to have to go back and redo this problem unless I really, really want to. But thank you for letting me know. Number 4, this is a graph of f prime, which is different than a graph of f, and there is not a shred of difference aside from the fact that has a different label. Again, this is a triangle. The triangle has a base now of 1, so base of 1, and a height of 6. 1 times 6 is 6. Divided by 2, the area of this should be 3. Finding the equation of this guy is going to be a little bit difficult. It's going to be, the bounds are 0 and 1, and our function is going to be, it has a y-intercept of 6, so something plus 6. What is the slope? The slope goes down 6, right 1. So negative 6x. So I'll say negative 6x plus 6, and then all of that dx. Taking the antiderivative of that is kind of a little bit painful, but you can do it. It's going to be negative 6x squared divided by 2 plus 6x, evaluation bar between 0 and 1. When I plug in 0, everything is going to be 0. So I don't have to worry about that. I just have to plug in 1. When I plug in 1, negative 6 times 1 is negative 6. So it's going to be negative 6 over 3 plus 6. Negative 6 over 3 is negative 3. Negative 3 plus 6 is 3. My final answer is still 3. On to number 5. So a slightly interesting shape. It's different than before because I'm gonna have to break this up into separate shapes. So I am going to break it up. Let's do Command Shift C. I'm gonna do a green to let me know that I'm splitting up into different. Come on, I said green. There it goes. Green to let me know I'm separating it into shapes. So I have a shape down here that is 1 by 2, so it has an area of 2. It's a rectangle, so I don't have to divide by 2. This triangle has a base of 2 and a height of not 5, but 4. Let's start at 1. From 1 to 5, I have a height of 4 here. So 4 times 2 is 8, divided by 2 is 4. So I should add up to an area of 6. I should somehow equal 6. Let's go ahead and see what is happening in terms of the function. So I'm evaluating between the bounds of 0 to 2. Those are the x boundaries. And what is my function? I have a y-intercept of 1, and I go right 1 up 2. Again, I went from 1 to 3, so I went up 2 when I went right 1. So my slope here is going to be 2x, and my y-intercept is going to be plus 1. All of this times dx. And you might be asking, is it really important that I know how to find that function? And the answer is yes. There are very frequently problems, especially on the free response questions, where you need to be able to rederive your linear function. And they won't ever give you something to derive that's quadratic or anything harder than that. But you should always know how to derive this linear function. So this is very good practice. It is useful, I promise. Okay, antiderivative of 2x plus 1. Antiderivative of 2x is 2x squared, divide down by 2, plus x, evaluation bar between 0 and 2. Once again, when I plug in 0, nothing happens, so I don't have to worry about subtracting anything. When I plug in 2, these 2's, by the way, cancel each other out. When I plug in 2, I'm going to get 4 plus 2, which is exactly what we got up here, 4 plus 2. So our answer is 4 plus 2, which is 6. Final answer, and box it. How are we doing on time? We get out of here at 52, which means I got 1 minute and 45 seconds. Let me see how far I can get through number 6, and then we have the backside to still do. Number 6. So we have, clearly our bounds are between 2 and 4. Dividing up this shape, now I'll divide it up like that. What? No, like, let me move this a little bit off. There. And then move this slightly back. Okay, so my area here is 2 by 1, so area of 2. 2 by 2 divided by 2 is 2. And then, I think that's right. Coming back down here, my function is really hard to derive. I have to pretend to continue on this function, and you can clearly, well, maybe not clearly, but you can probably see that the y-intercept is down here at negative 1. And my slope here is, I go right 1 up 1, so it's going to be x minus 1. My bounds are between 2 and 4. All of this dx. When I take the antiderivative, this is going to be x squared over 2 minus x, evaluation bar between 2 and 4. When I do that, when I plug in 4, I get 16 over 2 minus 4. And that's going to be subtracting when I plug in 2. When I plug in 2, I'm going to get 4 over 2 minus 2. And the answer here is 4. It does work out. Is equal to 4. Box it. All right, and on to number 7. So clearly our bounds are already listed for us. So between 2 and 4, let's go ahead and write what's happening graphically. I have a line here at 2, line here at 4, and my area is right here. Some people make the mistake of thinking, oh, there's my triangle right there. No, it's always between the x-axis and the curve, or the function in this case. So these ones are slightly easier. I just have to do the geometry. I don't have to take any antiderivative. This is a 1 by 2 rectangle. and then divide by 2 to get the triangle, so it's going to be an area of 1. This is also an area of 1. 1 plus 1 is 2. This next triangle, how am I going to split this one up? It's between 1 and 9, so it does end at 1 and 9. So I see a rectangle right here. That's 1 by 2, so an area of 2. This is 1 by 1, and then half of that is a half. I see I guess I can do this entire triangle right here. If I do that entire triangle, it's 1, 2, 3, 4, 5, 6 by 2. 6 times 2 is 12, then divide by 2 again to get 6, because it's a triangle. And know that if it's below, it's negative, so I have negative 2 and negative a half, and positive 6. So 6 minus 2 is 4. Maybe I can write down my work a little bit clearer down here. This is equal to 1 plus 1, that's easy. But this is going to be negative 2 minus a half plus 6. 6 minus 2 is 4. 4 minus a half is 3 and a half. 3 and 1 half. All right, so moving on to number 9 now. Integral between negative 2 and 2, so it's just the bounds that you would normally think between negative 2 and 2. I see a square here, a 1 by 1 square, so the area is 1. This is a 1 by 1 triangle, so then half of that is 1 half. Down here I have a triangle that has a base of 2 and then a height of negative 1, so it's negative 2, but then divide by 2 since it's a triangle, and I get negative 1. So this triangle and this square cancel each other out, and I'm just left with the half. Again, showing my work, I'm doing 1 plus 1 half minus 1 to get 1 half. I guess I should box this other answer. Moving on to number 10. I have 2 triangles. These are congruent triangles because I intersect at 6 and negative 6. So this area here from negative 6 to 0, that's a base of 6, a height of 3. 6 times 3 is 18. Half of 18 is 9. So that area is 9. That area is also 9. 9 plus 9 is 18. Over here, integral between negative 3 and 2, so make sure that I have my bounds correctly. Negative 3 and 2. How to divide this one up? So I'm seeing one giant rectangle right here. That's 1, 2, 3 by 1, so that has an area of 3. This triangle is a 1 by 1, so it's a half if I divide that by 2. This is 2 by 1, which is 2, but then I divide by half, or divide by 2 and I get 1. This triangle right here is the same as this triangle right here, so I could just think of those as canceling out, or I could actually do the math, I suppose. This is 1 by 2, which is 2, divided by 2 is 1, and therefore this is a negative 1. All right, so writing out all of my work, and I really like using the shortcuts of, oh, those are the same shape, they cancel each other out type of logic. So 1 half plus 3 plus 1 plus 1 minus 1, those are the ones that canceled out. So I'm really adding up just this area up here, and that's 4 and a half. 4.5 or 4 and 1 half, it doesn't matter. And our final question, number 12. Ooh, we get a circle in here. So between negative 2 and 3, so my bounds are still between negative 2 and 3. And this has an area of 1 times 1 is 1. Half of that is a half. I should do that in yellow to just be consistent, I suppose. This is a circle, so I can kind of think of the circle coming down here. The area of a circle, in case we forgot, area of a circle is equal to pi r squared. The radius here is this length right here, which is also this length right here, which is 1. So the radius is 1. 1 squared is 1 times pi is pi. So this whole circle is pi, but I'm only talking about half the circle, the semicircle. So that's pi over 2. That area right there is pi over 2. I have a half. I should switch that to yellow. And finally, this is a triangle that's 2 by 1, and then half of that is 1. So my answer is 1 1/2 plus pi over 2. So I guess I have 3 halves plus pi over 2, which is the same thing as 3 plus pi over 2. Either of those are final answers. Cool, and that concludes worksheet 5-7.